That's right. It's time for Virtual Mitchell again. All right, so I just want to talk about a few reminders with you guys before we get started with today's lesson. Don't forget you have a quick quiz on 2.7 tomorrow. So everything we've done this week, all related rate problems, are on tomorrow's quiz. It will be 3 questions, no multiple choice. So you'll have 3 different related rate problems that you'll have to do, and it'll be set up kind of like your class starter is today. You'll have those same boxes. So you want to draw a picture, write down the variables and the rates of change that you're given, write out the equation, then take the derivative of that, and then your final answer. So I want you to organize your problems like that tomorrow so you'll get a little practice today with the class starter. Also, don't forget your AP worksheet is due by 11:59 on Friday. These videos will also be on the website, so you can check them out on your own to review for the quiz. And any of the ones we don't get to in class today, you can also check out on your own. Tonight's homework is page 219, numbers 20, 25, 26, 43, and 45. That's on your calendar that I gave you. It's also on the website, but you might want to write it down somewhere so you don't forget. Okay, like I was saying earlier, your quiz tomorrow is going to be set up like this. There's going to be 3 different problems. I want to see you draw a picture when necessary, and pretty much always there is one. Write down what you know and what you need to know in this box. Figure out what equation you're using that relates all these variables. Take the derivative in terms of time, right here, and then show your work within this box or this box and write your final answer here. So I want you guys to go ahead and try this one on your own. You are going to have 5 minutes to do this. So please go ahead and get started. Of course, you can work with your group members as long as you're working together. Hey, you, get to work back there. I'm watching you. You better be doing your work. Put your phone away. One minute left. All right, go ahead and stop, and let's take a look and see how you did. Okay, you should get 24 divided by 5 pi inches per minute, or if you write that as a decimal, approximately 1.528 inches per minute. So we have our cone here. Height is 12, radius is 6, and the water level is at 5 inches. So we've got height here, 5 inches, and our variables that we know. It tells us that there's water being poured into the container at a rate of 30 cubic inches per minute. So we know that's going to be our change in volume with respect to time. So 30 cubic inches per minute. We want to find the rate at which the height of the water is changing when the depth of the water is 5 inches. So we're trying to find dH dt. So again, cone problem where we're just dealing with volume and height. We know that the equation for the volume of a cone is 1/3 pi r squared times height. It has that r in there that's not in the information that we know. We don't know what dr dt is in this case either. Now, we could figure out r, but that's not going to help us. We need to know dr dt. So instead of figuring out what dr dt is, we're going to get rid of r. Remember, I've told you this before, and you're definitely going to see a quiz question like this. We have to replace the r with something in terms of h. So if we look at this original picture, our cone has a radius of 6, a height of 12. So if we look at the ratio of radius to height, r over h equals 6 over 12. We want to solve for r, so we multiply both sides by h. So we end up getting r equals 1/2 h. So we're going to take that and replace r in the original equation with 1/2 h. We can go ahead and kind of simplify that a little bit, clean it up. 1/2 h squared, remember that has parentheses around it, that whole thing is being squared, so we get 1/4 h squared. We can multiply the 1/3 and the 1/4 to get 1/12 out in front. H squared times h, we get h cubed. So here is our equation. Come from here to here, but now we don't have r in there, so we don't have to worry about dr dt, we don't have to worry about product rule or anything like that. Now it just has volume and height. That's all we're dealing with. So we can take the derivative of both sides. We get dv dt equals 1/12 pi times derivative of h cubed. We get 3h squared dh dt. So the 1/12 times 3 simplifies to 1/4. Now we have our derivative. To find our final answer, we're just going to substitute the values in that we're given. We're going to put 30 in for dv dt. We're going to put 5 in for the height. Only thing left that's missing is DHDT, so we can go ahead and solve for that.